Our next topic is advanced plotting. The simple plotting techniques or functions are discussed in our previous tutorials. Now we are start with logarithmic plots. We can use log command, which uses logarithmic scales for both the x and y axis. We can also use semilog_y command, which uses a linear scale for x-axis and logarithmic scale for y-axis. Similarly, semilog_x command is used, which uses linear scale for y-axis and logarithmic scale for x-axis, which is just inverse of semilog_x. So here are some commands which are used, and output plots are displayed in the figure window. When you are using simple plot command, this will give you the figure as shown in the first window. Simple log space 1,10 log space graph or plot using a plot command. Our second figure shows the semilog_y plot, and third is the semilog_x plot, and fourth is the log command or plot. So this is the way you can write the program, and you can differentiate the various plots by using the different commands in the MATLAB. Next is other plots. The bar function draws a bar chart and bar h draws a horizontal bar chart. Like we want to plot population in various years. So we can write a year as 2013 to 2017. And the population is 0.9 in 2013, then 1.4, then 1.7, then 1.3, then 1.8 up to 2017. Now we can subplot. We have to plot 4 graphs. So we use subplot. In our first figure window shows the bar between year and population. This will be customized plot with the title bar, x label as year and y label as population in millions. Our second graph is bar h, which is customized as title with bar h, x label as population in million and y label as year. Our third plot is area. This will gives you the area graph between year and population. This is also a customized plot with the title area, x label year, y label population in million. And last subplot 2,2,4, which is our fourth figure. This is a stem between year and population. This will gives you the discrete graph, and this is also customized with title stem, x label year, y label population in million. So here are the 4 graphs. The area draws the plot as a continuous curve and fills in under the curve that is created, and stem draws a stem plot. I have already told you it is a discrete graph. For a matrix, bar h and bar functions will group together the values in each row. So for that, like group edges are given from 8, 19, 43, 25 and 35, 44, 30, 45. So there are 2 group edges. So bar group edges, x label group, y label edges. This will show you the graph as given here. Here the blue color displays you the 8 and 35 group edges of the same group with blue color, second with sea green color, third with yellow color, and fourth with maroon or brown color. Note that MATLAB groups together the values in the first row and then in the second row. It cycles through colors to distinguish the bars. The stacked option will stack the values. So you can also use bar group edges comma stacked to stack the values. This will gives you the figure as shown here. Next is histogram. Histogram is a particular type of bar chart that shows the frequency of occurrence of values within a vector. It uses bins to collect values that are in given range. Hist function is actually used to create a histogram. Simply just write any variable, like I have used quizzes and given some values, then I hist quizzes with and customize that plot, or c equals to hist quizzes. This will gives you the resultant as 1 0 0 0 1 1 1. This will be the frequency of occurrence of values. within a vector. This will show you the histogram graph. Next is pie chart. Pie function is used to create a pie chart. Simply just write pi and some values you want to display on the pie chart. I have using two plots, subplot 1, 2, 1 and pi with some values, and subplot 1, 2, 2 and pi with some values, and also given a name to that value a, b, c, d, e. So here is the difference or distinguish. You can distinguish both of the graphs, and by using that particular function you can plot the pie chart. Next is animation. To animate a graph, comet function is used. Movie function can also be used to display recorded movie frames. The frames are captured in a loop using function getFrame and are stored in a matrix. I have used here just given variable x and y and comet x and y. The results will be shown similar to the plot. After that, I'm using a movie function. In this case, I am going to show a movie of a sine function. So I am using this function. This will shows you the sine x graph or plot, we can say. It will shows you the movie of the sine function. Next, 3D plots. The functions used for 2D plots are used to create 3D plots with the 3 at the end. Like in 2D we use plot, but in 3D we use plot 3. Similarly, bar 3, bar 3h, pi 3, comet 3, stem 3, area 3 and so on. Like here I have displayed a 3D plot. Simply x, y and z, there are my 3 variables. I have to plot a 3D graph between x and y and z with stars. So I have used plot 3 x, y, z, k star in a quotations. So k is the color of that particular star. I am using grid here, x label, y label, z label to customize our plot and title as 3D. The mesh grid function can be used to create xy points for which z equals to function of x and y. Then x and y and z matrices can be passed to mesh or surf. So for that I am using command surf x, y, z or mesh grid with some particular value. So the graph will be displayed as shown here. Next is contour plots. These are two-dimensional representations of three-dimensional surfaces. So the contour and surf C commands are used to create the plot. Here in subplot first figure I am using the contour command, and in second figure surf C command is used, which will represent two-dimensional representation of three-dimensional surfaces. Next is pseudo color plots. It is a two-dimensional shaded map which is generated over a grid. Sample function called peaks that generates the x, y and z matrices of an interesting surface that looks like a mountain range. So for that p color command is used. So here is the function I have written here, x, y, z equals to peaks. Subplot 2 cross 2, 2, 1, where in first figure I have displayed the p color x, y, z. This is a pseudo color plot. Second figure gives the interpolated shading. Third figure shows the overlaid pseudo color and contour plot, and fourth figure shows the contour plot. So this is all. Thanks.